CORS misconfigurations.
Good afternoon, and welcome to Exploiting CORS Misconfigurations for Bitcoins and Bounties. Have you ever looked at a Bitcoin exchange and wondered how hard it would be to hack? Perhaps you heard about the recent theft of $60 million worth of Bitcoins from Bitfinex and thought, I wonder if I could have done that. Maybe you even took a look at a Bitcoin exchange and you saw a tangled mess of WebSockets, sub-resource integrity, content security policy, web application firewalls, cross-origin resource sharing, and thought, that looks like quite a lot of work to hack. In this session, I'll share with you how CORS' simplicity is its weakness, how that weakness leads to some really interesting problems, and how to exploit those problems to steal Bitcoins. Around 7 years ago, I just got into security, and I just read about these really cool things called buffer overflows. So on this particular evening, I was trying to exploit a buffer overflow in an FTP service by typing really long URLs into Firefox. And Firefox crashed. So I thought, great, I found a buffer overflow in Firefox. And I went on the Slackers IRC channel to ask, what shall I do with this remote code execution vulnerability that I'm just about to have in Firefox? And they told me about this website. And I can't tell you the real name, but I'm going to call it WeBuyOday. And the way this site works is anyone can sign up to it and submit the details of a critical vulnerability in a widely used piece of software like Firefox. And their team of internal experts will evaluate this vulnerability, and if they like it, they'll make an offer to buy the intellectual property from you. And if you accept the offer, then they get it. If you reject the offer, or they don't make any offer, then they will act as though they'd never seen that vulnerability. So it's a system built on trust. You have to trust that the company will do what they say, but it was quite a widely respected company. So it seemed like it worked. And I tried to build an exploit for this buffer overflow. It turned out it wasn't. It was a denial of service. But anyway, I submitted it anyway. Why not? And while submitting it, I noticed that this website didn't have any cross-site request forgery tokens anywhere. And I thought, okay, that's a bit weird. Looks like I can trivially make a page which will change someone's email address and hijack their account and get me access to all their 0 dates. That's kind of cool. And then I thought, what shall I do with this vulnerability? I know what to do. I'll sell it to these guys. So I went, hey there, I found this vulnerability. It's not in a widely used piece of software, but it is in your website. And it can be used to hijack people's accounts. Would you prefer to buy this vulnerability from me? Or would you rather act like you never knew it even existed? And somewhat predictably, they ended up buying it from me. And at the time, I was pretty happy with that outcome. In effect, that was the first bug bounty that I ever got. But in retrospect, I have to wonder how a security company that's staffed by an internal team of security experts, where all the users are also security experts, that's full of easily sold intellectual property, can have a trivial cross-site request forgery vulnerability that's really easy to find and exploit. I think the only answer is that back in 2009, awareness of cross-site request forgery was just really poor. The vulnerabilities were there, they were easy to find, but nobody was looking for them. And what I'm going to show you today is that that's where CORS is at the moment. First, I'll talk very briefly about the fundamentals of CORS from a hacker's point of view, and I'll focus on various limitations that are in the CORS design and implementation, and the workarounds that real websites end up doing to handle these limitations. And then I'll look at what goes wrong with these workarounds and how we can use it to steal Bitcoins and hack various other sites. And then I'll look at some more esoteric issues and ways to exploit CORS that are a bit less obvious. And then I'll talk about various mitigations that browser vendors, specification authors, and developers can take, and take 5 minutes of questions. So, who here is already familiar with the basics of how CORS works? Okay, cool. Most of you. That's good. If you're not, this one slide is all you're going to get, so please pay attention. CORS is about what a website can make your web browser do. Say that you own Gmail, and you want to let users embed their Dropbox files. You can easily make the user's web browser send a request to Dropbox, and Dropbox will send the response, but the web browser won't let Gmail read the response from Dropbox, thanks to the same origin policy, which is like what underpins most web security. But say that Dropbox actually trusts Gmail and thinks they have a reasonably secure setup and wants to let Gmail embed their users' files. That's where cross-origin resource sharing comes in. They can specify this HTTP header, which says they trust Gmail. And the web browser will compare the origin it's on, mail.google.com, with the one specified in this header. And if they match, then it gives access to that content. Now, by itself, that header only gives access to users' public files on Dropbox. If Dropbox wanted to let Gmail embed users' private files, they would have to add this additional header, which is called allow credentials, and set it to true. That means that the web browser will send the user's cookies when it fetches this file, and so private files can be accessed too. So that's the core concept of CORS. That's all a hacker really needs to know about the basics of how it works. And from that, it doesn't sound like there's very much potential for things to go wrong. And as long as Dropbox doesn't like typo that header, or Gmail doesn't get hacked, then it's not too bad. But what if Dropbox decide that Yahoo Mail also has a highly secure operation, and they want to trust Yahoo Mail too? You might think, from reading the specification, that Dropbox could specify a list of origins which they trust. But in practice, that doesn't work. You can only ever specify one origin. So what do you do if you want to trust multiple origins? Well, hold that thought. Also, what if you want to trust all subdomains of your site? You might know that CORS supports wildcards, but unfortunately, the only wildcard it supports is a star on its own. You can say you trust all origins, you can say you trust one specific origin, but you can't say, I trust all my subdomains, or something like that, which seems to be quite a common use case in real sites. Also, there's a special exception with the way that the wildcard is treated, which is if you use the wildcard in conjunction with the allow credentials header, web browsers will ignore the allow credentials header. This kind of makes sense because if you browse the web, you'll find random sites like developers.mozilla.org that inexplicably say they want to trust all their private data with every website on the internet. So this looks really scary, but in practice, it's not actually that bad. So what do you do if you want to trust multiple origins or all of your subdomains? You've only got one choice, which is to dynamically inspect the incoming origin header from the browser and decide if you trust it, and if you do trust it, reflect it back to the user. And making that flash is the only way I can do justice to how bad it is. It's bad because it's much more likely to be vulnerable. You've gone from a static, hard-coded value to something that's dynamically generated based on user input. But it's even worse than that because it's also, from what I can tell, much less likely to be discovered during a pen test. Because if you don't send any CORS headers when you're browsing, when you're doing a security audit, you won't see any CORS headers coming back from the site if it's doing dynamic generation. So you'll never realize the site even uses CORS. And I think as a result of that, you've got a whole bunch of sites where this security critical functionality, based on parsing user-supplied URLs, hasn't even gone through a security audit. So when I say people's awareness of CORS is really poor in this year, everyone's heard of CORS, but I think a huge number of people haven't realized how widespread dynamic generation is, because if you don't look for it, you just won't find it. So I'm going to look at what goes wrong with a bunch of sites that I found in the wild. All of these sites have bug bounty programs. So you can be reasonably sure that these have already been fairly heavily tested by other people before me. Also, when I did this research, I was extremely lazy. I used a 4-line curl script, and I didn't bother registering or logging in to any of these sites. So all the vulnerabilities I'm going to talk about in this section, they're real vulnerabilities, and they're low-hanging fruit. They're easy to find. Okay, first off, The simplest thing that can go wrong when you dynamically generate the allow origin header is that you just reflect whatever origin header you get given, which is surprisingly common for such a crazy behavior. I very quickly found a Bitcoin exchange, which I sadly can't name, that had this behavior. So if we look at the top request, this says, "Hi, I'm skeletonscribe.net. Can I access this user's private key?" Their private API key, that is. And this exchange says, "Yeah, skeletonscribe.net, you sound trustworthy. Have this user's private API key." And that means with a tiny bit of trivial JavaScript, I can grab anyone's private API key. And once I've got this API key, I've got quite a few options. The first thing to do would probably be to disable notifications on the user's account. As Bitcoin exchanges have a history of being hacked horribly, modern ones are very keen to show how seriously they take security. And one of the ways they do that is by generating email notifications for practically every action. If you sign in, you get a notification. If you change any settings, you get a notification. And if you make any trades or whatever, you get a notification. But that's cool because the API key can be used to silently turn off all notifications. After that, well, I probably enable two-factor authentication on their account tied to my phone, which just means they can't log in, and sets me up nicely for the next stage, which is just to transfer all their Bitcoins to an address of my choice, or to use their account to place trades. Because this is a Bitcoin exchange, if I were to compromise a decent number of accounts with this, I could potentially pump up the value of an altcoin and that I'd bought in on previously, and thus indirectly generate myself money without leaving a massive audit trail. Although because this is Bitcoin, leaving a massive audit trail isn't too much of a problem. When I reported this vulnerability, it was patched in under 20 minutes live, which is the fastest that I've ever seen a vulnerability patched. They were also kind enough to tell me that the root cause of this vulnerability was a vulnerable third-party package that just added these headers by default. So from what I understand, this exchange never actually intended to use CORS in the first place. It just kind of popped up there and removed all their security. Great. Other times, people try to validate the header, the origin header, but something goes wrong. Here, this is a different exchange that I also can't name for other reasons, and they're validating that the origin starts with btc.net. I think they think that the origin header might contain a full URL specifying a path and such like, and that's why they're doing this. But of course, that means they trust btc.net.evil.net, which is not great. When I found this, I thought, cool, I'll just find out how I steal Bitcoins from this site, and then that will go into my talk brilliantly. But due to the design of their API, I ran into some difficulties with that, and I couldn't actually prove that it was a serious security issue in the time I took. So I thought, I'll just come back to this later and have another go. And when I came back in a couple of weeks, I found that the site had just shut down completely. The company had ceased operations, and if you wanted your Bitcoins back, you had to phone them up. So that's why there's no proof of concept for this one. I'm not going to speculate as to why that would have happened. Just something to watch out for when you're dealing with Bitcoin exchanges, I guess. Something else that some sites do is they validate the end of the origin, and they forget to put a dot at the start. So here, I think they're trying to trust all their subdomains. This is Zomato. This is a real site. They have a bug bounty program, and they trust notzomato.com. Great work. Probably the most noteworthy thing here is the number of security headers they've got. They've got content security policy, strict transport security, content type options, XSS protection, and yet with 2 extra headers, they remove all their security. The other notable thing about this vulnerability is that it's possibly the least impressive bug bounty experience that I've ever had. I reported this issue to them and didn't get any reply. And I reminded them a few times, and I still didn't get any reply. And I thought, okay, whatever, I don't really care. I'll just full disclose it in 90 days. And after 90 days, I went to full disclose it, and I found that they'd fixed it. So they didn't reply to me, they didn't acknowledge it or give me any credit or anything. They're on HackerOne, but they did fix it. I'm not sure why they would do that. I think maybe they thought this was quite an embarrassing issue, perhaps. But, well, it's public now anyway. Okay, all three of those issues are quite obvious, provided you're looking for CORS issues. Now I'm going to look at some more subtle, perhaps more technically interesting ways to screw up CORS on your site. If you were paying attention earlier, you would have noticed that the specification has a reference to the null origin, which raises the question, what is the null origin? And I decided to spoof the null origin to a bunch of sites to see if anybody trusted it. And I found that Google's PDF viewer, which converts a PDF into HTML, trusts the null origin with credentials. So that's cool. And even better, there's a Bitcoin wallet that trusts the null origin. Excellent. You can find loads more sites that have explicitly whitelisted the null origin using Rapid7's sonar.http, which is a great resource, or using Showdown. So that just leaves the question, well, how do I get the null origin? Who has it? Accepted wisdom on Stack Overflow and the like seems to be that local files on your local file system use the null origin, and I think that might be why it ends up being whitelisted. But there's this great little HTML5 feature, which is the sandbox attribute for iframes. The purpose of this is to prevent the contents of an iframe from doing anything bad by isolating it in a separate origin. And you can probably guess what origin it puts the contents in. It's the null origin, yeah. So that means any website can get hold of the null origin. And thanks to that, I could still use Google account details like their user ID, their email address, nothing super sensitive, but some stuff you probably don't want every website you visit knowing. And I could also download encrypted backups of other people's Bitcoin wallets. And you might think, it's encrypted, what can I do? But luckily for me, it's encrypted with a password that the user chose on the website, which didn't even have a password strength meter at the time. And here I was able to launch an offline brute force attack against it. So that was potentially quite serious. So, in conclusion, what have we learned about the null origin? Well, it's actually the wildcard in disguise. If someone says they trust star, you can tell what they're trying to say. If they say they trust null, it's not immediately obvious that they're giving access to every site out there. But actually, it's worse than the wildcard. It's more dangerous because the exception with regard to credentials and the wildcard doesn't apply to the null origin. So if you say you trust the null origin with credentials, you are genuinely sacrificing the same origin policy entirely on your site. There's one other thing about the null origin. I think the choice of the term null was not ideal because from what I can tell, some frameworks, they let you configure which origins you want your application to trust. And if you don't bother to configure the value of this variable, then the programming language decides to output it as null. So you're trying to say, I don't trust any sites, and the end result is that you trust every site on the internet. Perhaps it should be renamed. Okay, let's look at a different, slightly subtle issue, which I'm going to live demo on Google Finance. Right, so here on Google Finance, we can see some share information related to my account. And if I was a hypothetically rich person, this share information might be really quite valuable. So let's see if the site is using CORS. I just realized that's not displaying on the screen. This won't take a second. Right, so we were just on Google Finance with some share info, and I've just sent a request and got it in burp. So I'm going to see if these guys support CORS. I'm just going to delete this token here because I can't guess the value of that, but it doesn't actually make any difference. Right, so first off, if you look at the headers you're getting back, there are no CORS headers there. So a tester that wasn't acutely aware of dynamic CORS generation might not realize the site supports CORS at all. But we're going to try an origin we think they're likely to trust, like google.com. Right? Google.com probably trusts google.com. And if we send that, then sure enough, we've got them trusting google.com with credentials. Fair enough, no security risk there. And we can try the obvious attacks of seeing if they're using starts with or ends with, but as you can see, we don't get the origin headers back. They're just not working. Also, if you try the null origin, then it causes an internal server error, but there's no actual vulnerability there. It's just kind of funny. But interestingly, they are trusting all their subdomains. So I can put anything .google.com. And that by itself isn't too bad, but they also don't validate the protocol. So here, https google.com is saying they trust http evil.google.com. Let's see if we can do anything interesting with that. Okay, so say that I'm accessing Google Finance, so I've got some sensitive share info on there, and you're in a position to view and tamper with my network traffic. Maybe I'm using insecure Wi-Fi in a coffee shop. Maybe you've done BGP hijacking on my company's office. That's kind of fashionable at the moment. Or maybe you're just the NSA sitting on every network, tampering with everything. Anyway, if I access Google Finance directly, that's protected with HTTPS. It's pretty difficult for you to modify, view, or tamper with that content. But as soon as I load any site over HTTP, you can intercept that request and spoof whatever response you like. So here, I try and load CNN.com, and you can redirect me to evil.google.com. And the browser will silently follow that redirect and load up HTTP evil.google.com. And once again, it's an unencrypted connection. You can catch that request and spoof the response. And now you're going to send some malicious JavaScript that's going to use CORS. It's going to use CORS to send a request to Google Finance. And the browser will put on this origin header saying, this request to Google Finance is coming from evil.google.com. But as we've seen, Google trusts that. So they go, great, that's a trustworthy origin, and pass my sensitive financial information back to your malicious JavaScript, which you can then log or send off to wherever you want. So although Google Finance is using HTTPS, they've kind of undone their use of HTTPS through their use of CORS. When I found this issue, I thought about reporting it to Google, and I wasn't sure if it was serious enough for them to care, so I sent them an email and didn't get a reply. And so I was like, fine, I'll just live demo it, because I don't think this is a serious issue, really. It requires a man in the middle. And a few weeks after my presentation, I got a direct message on Twitter, and it said, hey there, you know that vulnerability in Google Finance you demoed? Yeah, I submitted it to Google, and they paid me $1,000 for it. So, I'm not 100% sure of the truth of this. I haven't fully verified it yet, but my presentations might be more valuable than you think. Okay, you might now be thinking, great, I know how to safely trust all of my subdomains. I've just got to whitelist the protocol and use ends with a dot. But please don't do that. For a start, obviously, if any of your subdomains have cross-site scripting, you've just removed your security. And some even quite well-secured applications like Bugzilla have intentional cross-site scripting vulnerabilities on subdomains. It's a feature. It doesn't compromise the security of Bugzilla due to the way it's implemented, but it will compromise your site if you trust all your subdomains. Also, if you've got hanging CNAMEs and the like, someone might hijack a subdomain, third parties, all that stuff. Even if all your infrastructure is completely secure and there's not one XSS vulnerability in it or any of the third parties you're using anywhere, your customers, your clients' infrastructure can lead to XSS vulnerabilities in subdomains. Some unscrupulous ISPs, they detect a failed DNS lookup and they inject a fake search page, basically full of adverts to get some ad revenue. And these pages have a history of occasionally being vulnerable to cross-site scripting. So someone could inject something that does not resolve.yoursite.com. The ISP injects a page full of ads and it's vulnerable to JavaScript injection and you've just lost your security. In fact, recently someone found that McAfee Web Gateway, which is something designed to make your enterprise users more secure or something, had a very similar behavior. So only a few months ago, if you were using McAfee Web Gateway, this was introducing a cross-site scripting vulnerability into the page it showed for every domain name that didn't resolve. This is quite a good example of how adding security mechanisms can introduce vulnerabilities. If you just layer on complexity and additional layers, you'll get interactions between layers which remove your security. Okay, so far I've focused on exploiting sites that have said that allow credentials flag to true. That's because most of the time, if this flag is set to false or not specified, which just means it defaults to false, you can't do very much because you might as well send a request directly rather than using your victim to send it. But sometimes there's something about the user's environment which we can exploit. The very well-known case of this, which for the sake of completeness I absolutely can't skip, is that even if you don't allow credentials, if you allow access from arbitrary origins using CORS, you're losing a lot of any IP-based security that your site might have. For example, the IDE IntelliJ, which was for Java development, binds a server to localhost. So you can't access, as an attacker, you can't hit the server directly because it's bound to your victim's localhost. But someone found that thanks to their CORS configuration, they could ask this server, they could make you ask the server for your private SSH keys, which you would hand over to an arbitrary site. So that was kind of bad. And in fact, using a couple of additional issues, they got remote code execution, and they ultimately got a $50,000 bounty for this, which is not bad at all. I highly recommend reading the blog post. I submitted something to those guys recently, but sadly didn't get a $50,000 bounty. So if your site uses IP-based access controls, IP whitelists, or binding to an inaccessible network interface, you've got to be really careful with your use of CORS. Now for some more exciting stuff. If you read the CORS specification, you'll find a section titled Implementation Considerations. And that's a code word for hackers. Please pay attention to this section. It says, if you dynamically generate the allow origin header, make sure you specify vary origin. If you don't, then something may go wrong. And you might think, okay, specifying a static header, who could fail to do that? That sounds really easy. And I guess it is pretty easy. Probably the first people to fail to do this were the W3C, leading to this brilliant quote. I must say, it doesn't make me very confident that soon more sites will be supporting CORS, if not even the W3C manages to configure its server right. Well said. Couldn't have said it better myself. So, what happens if you don't specify this header? Well, most of the time, I think things will just not work. But sometimes, it's more interesting. If you've done a lot of web app pen testing, you've probably, from time to time, encountered an unexploitable cross-site scripting vulnerability that looks vaguely like this. So here, the problem is that the user's input that's being reflected is coming in the X-user HTTP header, and there's no way to make someone's browser send that header across domain normally. Now, thanks to the CORS headers that we can see in the response, we can send this header cross domain with some JavaScript. Now, by itself, that doesn't actually make this issue exploitable. Because we're sending this request with JavaScript, the response is just landing in a JavaScript variable. So our injected HTML isn't being rendered, It's just being stored in a variable. But if they haven't specified vary origin, then this response may be cached and may be served up on subsequent requests to this page. So just by appending a tiny bit more code, we can say, send this payload with CORS, and then we can redirect the user to exactly the same URL. And the browser will probably go, oh, I've already cached this response, and then show the user the page with the injected JavaScript. So you've cross-site scripted someone. And because this is exploiting the browser cache, a client-side cache, it's actually quite reliable. It works most of the time. If the stars are aligned, you might be able to get away with server-side cache poisoning. It's quite common for sites that reflect the origin header to reflect it regardless of whether it's actually a valid origin or not. And Internet Explorer regards a carriage return, i/r, as being a valid terminator for a HTTP header. So when it looks at the response to that request, it sees an additional content type header which changes the char set to UTF-7, which is great for triggering cross-site scripting vulnerabilities. And once again, by itself, this isn't much good, because there's no way I can make your version of Internet Explorer send such a dodgy origin header. But what I can do is use burp and manually send that origin header myself, and then hope it gets cached on the server side and served up to other users. And if the vary origin header isn't set by the server, that's not implausible. So that's cool. In theory, you can have any kind of vulnerability in the processing of the origin header, like someone could be using it in a SQL statement, but this is a vulnerability with it that I've actually seen quite a few times. So what have we learned? Firstly, most importantly, if you're a pen tester, make sure you look for dynamic generation of CORS headers. Whenever you test a site, you've got to specify an origin header that you think they're likely to trust to try and coax them into revealing this functionality. And then if you do find it, just audit it, see if it has any of the vulnerabilities that I've mentioned. The Burp Suite scanner will, of course, do this for you automatically, as of fairly recently. But it won't build an exploit for you, and that's probably where the most fun is to be had. As far as the specification goes, well, I think the wildcard exception with credentials has been a good thing for security, because we've seen it save sites like developers.mozilla.org. But I think it should be applied to the null origin too, because that's just as dangerous, or it's more dangerous at the moment. I actually suggested this to the W3C earlier this week, and someone from Dropbox replied and said, actually, Dropbox relies on having credentialed access to the null origin. So that might be problematic. I just need to persuade them to implement it in a different way, and we might be able to push that forwards. Also, I think the specification should allow for partial wildcards to let people with a static value trust all their subdomains and reduce the number of sites forced to do dynamic generation. As far as browsers go, I definitely think they should allow multiple origins to be specified in a static way in this header, because once again, that reduces the number of sites forced to do dynamic generation, which is risky coding, and it's often implemented in weird places like in Apache configs and stuff, rather than in actual code where it's likely to get a proper review. Also, browsers could take the opportunity to block reverse mixed content, basically that issue that I showed you on Google Finance. Browsers already block HTTPS sites trying to load scripts over HTTP, but they'll very happily, as we saw, let a HTTPS site grant full access to a HTTP origin. So why not just block that too? If you're a developer, well, if possible, don't do dynamic generation of CORS headers. That's the safest approach. But if you have to, validate with caution, make sure it gets a security audit, and don't forget to verify the protocol, and always specify vary origin. And never trust null. That goes for you too, Dropbox. Okay, you can grab the slides, and then there's a write-up of the core technical content of this online. And the three key things to remember are that CORS misconfigurations are often critical, sometimes subtle, and absolutely out there if you look for them. I'm going to take 5 minutes of questions now, and if you have any more after that, you can come and speak to me at the back. And also, if you've got any questions about the certain interesting interplays between vendors and the latest OWASP top 10 and number A7, I'd be very happy to talk about that as well. Yeah, don't forget to follow me on Twitter. Thank you for listening. Sorry?
Why did the audio suck so much during the whole presentation?
The what?
The audio.
Oh.
Maybe a question for you.
Does the flag allow credentials? Does it work only with cookies?
I think it allows basic auth
Basic auth.
too,
Okay.
but it won't allow, like your random X header that you've got some JavaScript sticking on, because that's not like a browser handled credential.
Okay, thanks.
Any other questions at all? No. Thank you very much.
Okay, cool. Thank you.